Okay, this is part 2 of Unit 7A. We're looking at probability here, and just kind of an introduction. So we looked at probability, the chance of something happening. Another word is kind of like the likelihood of something happening. And we're going to look at now the probability that an event not occurring. This is sometimes referred to as the complement. And here's how this works. If the probability of an event A is P of A, we write the probability that the event A does not occur as P of not A. Now, there are different iterations and ways you can write this depending on the textbook. This is how our text writes it, so this is how I'll refer to it. Now, because an event either does or does not occur, the sum of these probabilities is always equal to 1. So the probability that it occurs plus the probability that it does not occur is 1. Because it either happens or it doesn't happen. There's a 100% chance of that. And that's what the 1 is. Again, thinking of when you see 1, that's 100%. So the event that the probability not A occurs is just 1 minus the probability that A does occur. When we manipulate, basically we just subtract P of A from both sides. So if we look at this, then we want to find the probability that an event doesn't occur here, and first we have the probability of not rolling a 1 with a fair die, and so it's 6-sided dice. The probability of not rolling a 1. Well, let's look at in our dice, what's the probability of getting a 1? Well, the probability of getting a 1, there's 1 out of 6 chances, so 1 in 6 or 1/6. That's the probability of getting a 1. So the probability of not getting a 1 is just 1 minus the probability of getting a 1, or 1 minus 1/6, which is 5/6. So there's a 5/6 chance that you do not get, if this will show up on the screen there, that you do not get a 1. Now that may seem quite obvious, but this will be much more applicable when we get a little bit further down the road. So now we're going to be looking at what's the probability of not tossing 3 heads with 3 fair coins. And so when we look at this one, we had that example of all the possible outcomes of 3 coins. So it was heads, heads, heads. Then it was heads, heads, tails. And again, we'll just write all of these out. It was in the chart up above, and everywhere you see a T, that is a tails, and a H is a heads. So there were 8 possible outcomes, again, because there were 2 for the first, 2 for the second, 2 for the third, so 2 times 2 times 2 is 8. So there should be 8 possible outcomes. So we know that the total number of outcomes here is 8. And first let's look at what's the probability of getting 3 heads. Well, the only time you get 3 heads is this one time right here. So this is the probability of getting 3 heads. Heads, heads, heads. So the probability that it's not heads, heads, heads is going to be equal to 1 minus 1/8, which is 7/8. So you have a 7 out of 8 chance of not getting 3 heads when you toss 3 fair coins. Okay, and so again, this idea of not or the complement gets really powerful when we get into much more complicated ideas, but hopefully this, just getting the feel of this, of having one and then being able to find, not that one in the next round, hopefully that was helpful for you. Okay, the next thing we're going to look at is this idea of odds. You hear a lot of things, what are the odds for, winning this game, or what are the odds against the team who's the underdog, or whatever. So when you hear this idea of odds, here's another application of this probability of A and probability of not A. The odds for an event A is the probability of A divided by the probability of not A. Then if we look at the odds against some event A, then that's going to be the probability of not A divided by the probability of A. And I'm not sure why those things are taking so long to appear. So those are the basic definitions for finding odds of an event. So for example, we want to find the odds for and against for each of these examples. So the rolling a fair die and getting a 5. So the probability of getting a 5, well, there's a 1 out of 6 chance of getting a 5. The probability of not getting a 5, so probability of not A, if our event A is getting a 5, is just 1 minus 1/6, which is 5/6. So the odds for event A, you'll take 1/6 divided by 5/6, and you can think of this as 1/6 divided by 5/6. So this is 1 out of 6 times 6 out of 5. And it turns out that those denominators are going to cancel and you'll get 1 out of 5. And that'll always happen. You'll see these denominators canceling right here when they're the same. Those 6's will cancel out. So when you get 1 out of 5, the odds are, when we say the odds are 1 to 5. Okay. And those are the odds of getting a 5. You have a 1 to 5 odds. And then the odds against turns out to be the reciprocal. So in this case, you would take the probability of not A divided by the probability of A, and this just turns out to be 5/1. So you get 5-to-1 odds. So you have much greater odds or better chance of not getting a 5 versus getting a 5. And so again, you can write it in English. Sometimes you'll see it written with colons, like 5:1, 5-to-1. In this textbook, it writes out the word 2, so we'll roll with that. Okay, and this next one, randomly drawing a heart from a standard deck of cards. Okay, well, heart is 1/4, so the probability of our event A is, 1/4 of the deck is hearts, so we'll say that's 1/4. And so then if we are going to go through here, then the probability of not A, I should say, is going to be 3/4. So the probability, or excuse me, the odds for A is going to be the probability of A, which is 1/4, divided by the probability of not A, which is 3/4, and that reduces to 1/3. So that's a 1 to 3 odds. I don't know why this is not showing up on the screen. I apologize for that. Okay, if we go odds against, okay, our odds against are going to be the probability of not A, which is 3/4, divided by the probability of A, which is 1/4. So that turns out to be 3/1 or 3-to-1 odds. So that's how we calculate odds. That's where we use this idea of probability of not A and the probability of A. Let me just check my time here. Okay. So here's the basic idea of what we call relative frequency probabilities and subjective probabilities. So you can read up here if you'd like to, but basically a relative frequency is you repeat or you observe a process many times and count the number of events of interest where A occurs. So this is an estimation for the probability of A, and it's based off of observations. So if you do an experiment, you look at the number of times that your event occurred divided by the total number of times you actually did this observation. So if you were to flip a coin 100 times and say 47 out of the 100 were heads, then you'd say the probability of getting a heads is 47 out of 100, and this is what we call a relative frequency method, and it's an estimation of that probability. And the larger your number of observations get, or the more times you do your experiment, the closer this relative frequency method gets to the actual theoretical probability. Okay, the subjective probabilities, they're a little bit more vague, not as reliable. but it's used to, again, it's used to estimate. So both of these last two are used to estimate. And these are based off of using experience and intuition. So if someone has a lot of experience in a certain field, and they make an estimate, that is what we call subjective probability, where they're using the experience they have, the intuition, the know-how that they have to make an estimation on the probability. So you'll hear people throw these out. I think that the likelihood of this happening is, 4 out of 5 or 4/5. That's a very subjective probability, especially if it's just someone's opinion. But again, you have to look at that person's experience and intuition. So the things we are going to be sticking to in this chapter, or at least this section, is theoretical probabilities. Okay, so here's computing some probabilities. So decide whether each of these methods are theoretical, relative, or subjective, which method is appropriate, and then compute or estimate the following probabilities. So first, it's probability of drawing a red face card, so a red jack, queen, or king from a standard deck of cards. Yeah, this is definitely going to be theoretical because it doesn't ask us to do an experiment, and we're not giving our experience or intuition. This is just in theory what it would be. So a red jack, there are 2 red jacks, there are 2 red queens, and there are 2 red kings out of the total standard deck of cards, which there are 52 of those deck of cards, or in a deck of cards. So we get 6 out of 52, which reduces down to 3 out of 26. So that's the probability of drawing a red face card when you just draw one simple card. Okay, next, rolling 3 dice and getting the same number on all 3. So you have to think about, if you roll 3 dice, how many outcomes are there? Well, you have 6 outcomes for the first dice, the second has 6 outcomes, and the third has 6. So there are 216 possible outcomes. So that's going to be the number of outcomes possible, 216. And then we want to get the same number on all 3 dice, so that's going to happen in a couple ways. So you can get all 1s, you can get all 2s, all 3s, 4s, 5s, or 6s. So there's 6 different possibilities there where you get all 1s, 2s, 3s, 4s, 5s, or 6s. So there's 6 different possibilities there. So the probability that you get the same number on all 3 dice is 6 out of 216, or 1 out of 36 if you reduce that fraction. So basically, in 36 rolls, you would anticipate that happening once in those 36 rolls. So lastly, we want to find out what's probability. Oh, and this was definitely theoretical as well. Number 53, I'm just going to put it down, theoretical again. So what's the probability of randomly meeting someone born between midnight and 2 a.m.? Okay, now if we assume that everything is fair, that that there's an equal chance of being born at any hour on any given day, then the total number of hours that someone could be born, there are 24 different hours, and if it's between midnight and 2 a.m., okay, that is 2 hours of time, so 2 out of 24, or 1 in 12. So if the probability of meeting someone who's born between midnight and 2 a.m., some random person, you have a 1 in 12 possibility that they were born between those 2 hours. So that's a look at probability, and that ends Unit 7A for us. If you have any questions, please do not hesitate to let me know, and I appreciate your time in watching this video.